So we're looking at, going back to those of you that were in Benjamin's presentation, looking at house prices, and then maybe a bit related to the first presentation related to GIS. It's quite a big team. I guess it sort of explains that this is a bit of an interdisciplinary effort. So we have people from accounting and finance, well, mainly finance people. We have the School of Survey involved. We have people from economics. We have GNS Science, which is a Crown Research Institute. So we, as you'll see as I go through the story, we've had to involve geologists in this exercise to try and get some sort of realistic models. Okay, so we're going to look at the risk to residential property values and sort of climate change related flood hazards. Let's just make sure I can go forward here. Yeah. So it has two components. It has an empirical component and it has a GIS forward-looking modeling. Actually, we started off pretty ambitiously with all this. We're actually going to split it into two papers. I'm not really going to talk too much about the empirical bit. It's reasonably standard. Results aren't too different to what the literature would expect you. I'm really interested in the hard bit, and I'm going to be really honest about the problems we've experienced in terms of this GIS forward-looking modeling. I'll give you some initial conclusions, but a lot of next steps. And as I intimated, we involved a geologist because what we're finding is with very simple models, you get very unrealistic outcomes. So why did we get interested in this? So those of you that live near coastal areas that haven't heard of before the flood, if you type into Google before the flood map, put in your city, you can add various levels of sea level rise, and invariably you'll see your city disappear. In Dunedin, in New Zealand, where we live, this seemed to happen, and there was some sort of fairly high-profile media reports in the local newspaper, to say there was panic maybe is an exaggeration, but a great deal of concern. And so what we wanted to do is look at it in the context of Dunedin. So if we had a research question is, what is the impact of this climate change related flooding hazards on residential property values? What is the magnitude, and what's going to be the timing? Okay, so we sort of begin to answer the magnitude question. The timing, we've still got a way to go there. So we're looking at something called Greater South Dunedin, and I'll show you a picture of that. I'll show you a picture of that now. Okay. The tourism board didn't ask me to put this up. There's a reason I've told you that is. One of the reasons I sort of wanted to show you that is it's that lower part where you're seeing all the buildings. And you've got water coming from the sea, you've got water coming from the bay and off the side of the peninsula. And what you can't tell from the picture also is there's hills either side of that flat bit. So it's going to tell you you're going to have problems of groundwater and surface water to contend with. It's widely regarded as one of the areas in New Zealand that is most vulnerable to sea level rise. We have quite a lot of areas, so the majority of the population lives within 5 kilometers of the coast, and 85% of our assets are in our properties. Yeah, New Zealanders don't really like investing in the stock market. The stock market's small, so it has potentially large impacts on the economy. So what we wanted to do is also have a sort of an analysis that sort of looked at the cost of doing nothing, so that it could be input into cost-benefit analysis. Our local council is definitely has been helping us in this process. So as I said, the analysis has two components. So empirical analysis, fairly similar to the paper presented earlier by the Bank of England. The council introduced something called a minimum floor area. So if you were within a certain area of what they regarded as vulnerable to flooding, then you had to build your house at a certain height. Also, we had a very large flood in June 2015, which gives us really our empirical event to run our difference in difference analysis. So I'll go through those results, but then the main interest is around this forward-looking modeling. And so we use IPCC scenarios of sea level rise. Then we add to sea level rise high tides, so every fortnightly high tides. And then we sort of simulate a high alluvial effect through sort of replication or the effect that the June 2015 flood had. We actually want to add weather forecast models from NIWA to that, but as you'll see, we're still trying to get our base model looking sensible. So this is a sort of a GIS map of the area, and so the little dots were measurements on the date of the flood. The area that is grey was area affected by the flood, and that's actually quite important to our story. But the really high areas affected by the flood were in that top left-hand corner. And the shaded, the striped areas are the minimum floor area. So for our empirical analysis, we had a data set that included 34,000 transactions from 2000 to 2018. And so descriptively, it looked like something happens. Yeah, so we've got Dunedin house prices in the dashed line, and those in the South Dunedin area in the bottom line. And just descriptively, it would seem that there seems to be a little bit of a divergence. But we do a sort of traditional hedonic analysis. We have a lot of data, actually. So one of the great things about New Zealand is, they're very great at gathering data. So we have structure characteristics. We've got floor area. We know how many bathrooms they've got. The data set's incredibly rich. We have neighborhood characteristics, so age, etc. We have locational attributes and amenities and disamenity measures in there. And we use a hedonic and a matching estimator. We use propensity score matching plus a nearest neighbor, a variety of different ones. Our results are really in line with the literature, in line with what we saw earlier today, which was a sort of discount of between 5.9 and 3.1%, depending on which of the models. We did all sorts of all sorts of models. Roughly in line with the literature that exists. There's an awful lot of these backward-looking analysis. Something that I think is quite interesting from the analysis is that we looked at the effect of prices immediately after the event, and then over time up to about 36 months. Okay, and so like any shock to a market, there's a large correction, but the effect dissipates over time. Yeah, and so that 5.9 to 3.1 is really the long-term effect of having your property flooded. Yeah, so there's this shock, and this sort of relates to some of the modeling we want to do later, because one of the things that's going to happen with these flooding-related hazards is that they're going to, with higher sea levels and potentially more storm surges and so on, the return periods are going to increase. So that sort of correction, not correction, but that sort of dissipation of the effect may not happen, or the next event, the next shock may come quicker than the correction, for the correction to fully happen. In terms of the forward-looking modeling, we really use sort of LiDAR data. As I said, we model just sea level rise. We use high tides and rainfall based on the June flood. We use IPCC AR5 scenarios, and we use a Monte Carlo simulation to sort of deal with the data error that is inherent in LiDAR. So there's plus or minus 15 centimeters, and also there's obviously a range within each of those IPCC scenarios. And then we try and get to some of the values that we have various measures. So, what land area is impacted, what value of land is impacted, or what value of housing is impacted. So we've got, house prices in there as well. So, okay, and so this is RCP 2.5, and I think that's 1.8 degrees, I think is, other people can correct me if that's not wrong. We get some permanent inundation on the right-hand side. And to be honest, that's not really where we expected, because if you remember, when we had the flood, it was in the top left-hand side. So this is a bathtub approach. So for those of you that don't do GIS, it really is what it says on the tin. You fill a bath and everything goes up, okay? And you'll see there are problems with that. So we can go through the various scenarios. So this is RCP 4.5, I think that's like 2.2 degrees warming. And then we've got RCP, I think that's 6.9, that's 2.2. And then we've got the RCP 5, which is much higher warming. And so the black areas are permanent flooding, yeah? So, if we've got RCP 8.5, we would probably have to retreat from the area or get some good Dutch engineers to sort it out. Actually, one of the things I haven't said is actually this is a really poor area. So unlike the Bank of England area, these are really, apart from the bits near St. Clair where some of the rich people have houses slightly up on a hill looking at the sea, this is a real low socioeconomic area. I think there's interesting research around this stuff, that it's those that are wealthy that tend to have manage to persuade authorities to do stuff. So here's some of the data in terms of which areas were affected. So we have number of properties affected, rateable value. So rateable value is like council tax value. So you pay your housing tax based on what the valuation of your property is, and it's a fairly good proxy for what house prices are. So at the moment, Dunedin house prices have gone slightly crazy. We're the best performing housing market in New Zealand. So you would add 100,000 to rateable value to get a market value. But they're a reasonable estimate of market value, and then you have it for each of the IPCC scenarios, and we're talking about close to a billion New Zealand dollars of properties affected. Actually, the different scenarios don't make a huge difference there. We also have it by percentage of affected properties and percentage of rateable value, the results. Our initial conclusion, the market is pricing a discount, and actually some of the interesting literature, I think it was in Ecological Economics, there was a review of this, and the discount is really often associated with how much people believe in climate change. So if they believe in it, then they're more likely to discount the area more severely. So I think it's roughly in line with other studies. I say low relative to other studies, but we just had the Bank of England one. That was around the 3% mark, so it seems to be in line. One of the things we took away from, this scenario is probably unlikely, RCP 8.5. I mean, I don't think anybody seriously thinks we're heading that way. These more intermediate scenarios don't look so bad, and so you might conclude permanent inundation isn't a big concern, yeah? You could have periodic inundation, but permanent inundation is the black bits on the line. But, we've been thinking quite a bit about this, and, an asset will be stranded well before it's permanently inundated, and I'll show you how we're hoping to model that going forward. What else? We conclude that it'll affect around a billion worth of property, but we started looking at our results, and we could have just gone and tried and published them, but we have a problem, Houston, okay? So if you look at the value column there, what we're doing for this column and that column, what our bathtub modeling is doing is inundating properties that contemporaneously that aren't flooded, okay? So this tells us the bathtub approach is probably not a great way to go. And to be honest, there's a lot of people doing this, and a lot of these maps that you're seeing are based on bathtubs approaches. So, we could have just tried and published it, and I thought, no, we don't want to do that. And so we got Simon, who is a geologist, involved. The first thing he said to me is, I don't like bathtubs. We've been having long discussions with him, and what we really need is a hydrological model of what's happening under the ground. Yeah. And unfortunately, there isn't one for South Dunedin. There's a very good one for Canterbury, and we're going to look at Canterbury next, Christchurch, sorry. But he's starting to build one. We do have groundwater measurements, so he goes and bores holes and measures the distance to groundwater from boreholes. And so he's given us that data, and so that gives us a sense. So the dots are the boreholes. And so the lighter, the top left-hand corner, remember, is how close you are to the water. And that was the area that flooded, yeah? In our modeling, the area on the top right is flooding the worst, and actually contemporaneously in June 2018, it was top left. Okay, so this gives us a better estimation, okay? And so it's in the right area, but we're flooding an awful lot. Much so unrealistically. So one of the things we're going to do next is use these groundwater table measurements and add distance from the coast as a decay function. We also want to incorporate other hazards. So when we presented it to the council, we thought we were being very pessimistic, and they said, what about storm surges and a combination of hazards? But what really appeals to me here is modeling the time dimension of this thing. Because, a high tide right now may not have flooding, but with sea level rise, it will increasingly have flooding. Okay, and so this is going to affect property values, and I sort of started to develop a model around that very simplistically. So this would be like the value of the property, as you saw in our empirical thing, where you have a flood and it sort of gradually dissipates. But as the frequency of those floods increase, the market isn't going to correct. Yeah? And eventually you're going to have your asset stranding. And that's all about what they call return periods, how quickly these floods are coming back. So markets can handle large one-off events, but once you start flooding on high frequency, then banks are going to withdraw, or insurance companies are going to withdraw, and you could end up with an asset that's stranded well before you're permanently inundated. If you take nothing away from this is Manhattan, so, and this is from before the flood, is that and I actually don't think they use bathtub, they use something similar to the approach we used that uses measurements to groundwater, but there's a lot of problems with these models, so we should be really careful, and I've put their caveat that's in there, that you shouldn't use these things for planning. No, you shouldn't. You really need to develop much more sophisticated models, and we're at best halfway there.